So after rectangular prisms, we're going to look at and kind of dissect a triangular prism, which um, these are kind of hard to explain. I've got a couple of pictures that hopefully will help you see what's going on here. I know some people have a hard time taking a 3D shape in their head and kind of unfolding it and seeing what it looks like. So if you're in person, if I will see you today, um, feel free to stop by my room. I've actually got a couple of these. It's called a net. It's a solid that you can flatten out and see what really makes it up. And since we're doing area, that's where we really need to kind of focus on. You know, if I take this 3D shape and I cut it open and lay it out flat, because that's what area is. Area is a flat two-dimensional measurement. We need to be able to see what the component pieces are of these things. You know, what really makes this thing up. With a box, I think it's pretty easy because, um, I know I break down cardboard boxes at my house all the time when we get stuff shipped to us or whatever, and you can kind of see what it flattens out as. So triangular ones are a little bit trickier. So the idea is I've got this kind of wedge like a doorstop, and the front face of it is a triangle. So just to kind of how this is labeled, I want to talk about that for just a second. So I've got this triangle out front that has sides 6, 8, and 10 in the back. Now I put it in the back so it was a little bit, it wasn't kind of getting mixed in with the other ones. So the triangle out front is 6, 8, 10. And then the length of the box, since it's laying down flat, is the 12 out here to the side. So if I cut that and lay it out flat, here's what I'm looking at. I've got two triangles that are 6 units tall, 8 units long. And that 10, if you can kind of see, if you can kind of fold this up in your mind, the 10 that was this length here, this diagonal length, should be the same as this length here. And same thing down here. The 8, this horizontal piece of this triangle, winds up being this piece of the rectangle in the middle. So when this thing's laid out and flattened out, I wind up getting the two triangles on the sides and then these three different rectangles through the middle, which all have the same width. They're all 12 units wide because that's how tall this prism was, right? This measurement here is telling me how far it is between the triangles. So that 12 is the width of the rectangles, and then each side of the triangle winds up being the different width of the triangle. Okay, so what I wind up with as far as the area, I'm trying to piece all these things together. I've got two triangles and three rectangles. So we're going to have to find those separate areas and kind of piece them together. Now this is different from our rectangular prisms because when we did the rectangular ones, I had pairs of sides that were all the same. So I really had to do half as much work and then I doubled it. The triangular ones are a little bit different, but the good news is I have two identical triangles. So I don't have to find those separately. And you may need a refresher. Area of a triangle is 1/2 base times height. So I need to be able to find the base and the height of each of those triangles. Okay, so here's what I'm looking at. I've got two triangles. In this particular example, each triangle is 1/2. The base of the triangle was 8. The height of the triangle was 6. And then I've got three separate rectangles. Now, a rectangle is pretty straightforward to find the area of. It's what we've been doing, length times width. So I've got a 10 by 12. I've got an 8 by 12. And I've got a 6 by 12. Those are all getting added on. Those are multiplications, not decimals. Okay, so if you kind of look at this, before I multiply it all out and give you an answer, if you look at this, I've got the triangle, which was right there. It was this I highlighted in purple here. I've got the triangle. There's two of those. And then each rectangle is basically the 10, 8, and 6. They're the sides of the triangle. Right, one at a time, you take the side of the triangle and you multiply it by how tall the prism is, how far it is between the triangles. That's why this 12 gets repeated, because every rectangle has that same width of 12 every single time. So once you get this set up, you just need to grab a calculator and you start at the left and you type it straight in. Multiplication where the multiplication's at, addition where the addition's at. That is, I'm going to double check that because that's a big answer. Yep, hit a multiplication instead of addition. $336 square centimeters. Okay, I would grab a sheet of paper and kind of write this stuff out, because just trying to do it start to finish on a calculator, I think you're going to mess it up. You've got 2 triangles and then 3 separate rectangles, but the rectangles all have the same width. They're all the same unit wide. It's just that their height is going to change because those heights have to match up with the triangle because of the way it folds. Okay, focus on the triangles, do those first, right? I've got 2 triangles. Each triangle is 1/2, and then the base of the triangle, the height of the triangle. Base of this one's 12, the height is 9. And then I'm going to go into my rectangles. My rectangles are all 6 inches wide. 6 inches wide, but the lengths wrap around the triangle. So I'm going to have a 9x6, I'm going to have a 12x6, and I'm going to have a 15x6. Now, the order I did those doesn't matter. I just happened to start with the 9. I could have started with the 12 or the 15. It doesn't matter. It doesn't even matter that 9 came before 6 when I'm multiplying, because of the way multiplication works. So this one is 324 square inches. Don't forget your units on these. Okay. The only thing that could possibly change on these is that the triangle out front is not a right triangle. That doesn't change anything. It's still 1/2 base times height. It's just that your height may not be a side. And I've got a couple of those. So I'm gonna make this one go a little bit faster here. I've got 2 triangles. Each triangle is 15 by 8 by 8. And then I've got an 8 by 9, a 15 by 9, and a 17 by 9. Okay. That is 480 square feet. All right. All right, this is what I was talking about. The front end is still a triangle, but it's not a right triangle. So it might look like there's an extra measurement there. That dotted line through the middle is how tall the triangle is. That's what you need for the height of the triangle when you find the area of the triangle. But it doesn't get used when you're doing the rectangles like the right triangle did. So this guy, I've still got 2 triangles. Each triangle is 1/2 the base of the triangle times the height of the triangle. And then I'm going to walk around the sides of the triangle times 11. I've got a 5 times 11. I've got a 6 times 11. And I've got another 5, plus I've got another 5 times 11. That is an even 200 square yards. Okay. Last one. I know this video is running a little bit longer, but I just really wanted to explain the kind of how it all folds out. 2 triangles. So each one of those triangles, it has a base of 10 and a height of 12. And then I've got a 13 by 14 side. I've got a 10 by 14. And I've got another 13 by 14. $624 square yards. Okay. Your homework is a Google form, just like we did for the rectangular prisms. When you put your answers in, make sure you include the units. If you don't put the units in there, they will get flagged as incorrect.